Welcome to section 2.6. This section is entitled De Morgan's Laws. And in De Morgan's Laws, we're going to learn about equivalent statements for the negation. And so if we consider something like, like an example that I've used in a past video, if I go to a neighboring classroom and I look to see what's being taught and who's teaching it, and I want to know about the individual being teaching math or being a woman, I think is what I used in the previous video. I would be happy if I go in and see somebody teaching math or a woman. So we know what that means. If I go in there and teaching math, I'm successful regardless of gender. If I go in and it's a woman teacher, I'm successful no matter what the subject is. If it's a woman teaching math, right? If it's my colleagues like Michelle Chang, Joy Fuson, Lily Schroeder, Kim Armbrust, then I'm successful as well. But I really only need one thing to happen. So for example, I can go in and see my colleague Kevin Pipkin teaching math, who's male, right? I would be successful because he's teaching math, even though he's not a woman, right? I would be successful if I watched my colleague Danielle Beck, who's a woman teaching a class, even though she's teaching psychology and not math. The only way I'm going to fail is if the person is not teaching math and not a woman. That is where I would fail. So I want you to keep that in mind. So De Morgan is a mathematician that was looking at essentially equivalent statements and made some connections. They're actually easy connections that we could have made on our own, but since he did it first, they're named after him. So keeping that in mind, that the only way for that or statement to fail is for both the subject matter of math not to being taught and the gender of a woman not being met. That's exactly what De Morgan's Law says. So there's actually 3 statements as for De Morgan's Laws that I can think of. And here's what they are. De Morgan's Law says that the negation of an or statement, what we were working on, is 100% equivalent to negating each one, but having an and in between. So notice there's 2 switches. I'll highlight something really quick. You want to make sure that these things flip over. The negation of an or is for both things not to happen, and needs to be there. And so let me come in here and get rid of that highlight. The next one is very nice as well. It's the negation of an and. Well, you can distribute that negation through, didn't mean to switch the order. The negation through, but we do need to change it to an or, right? So the negation of an or is an and. The negation of an and is an or. You distribute that negation through, but you do have to flip that sign over. Another interesting one that he's able to prove is that the negation of the conditional is the first thing happening and the second thing not happening. But that's exactly what we knew would happen. So in order for this to be true, so let's think about a conditional statement, one that I've used in a past video. If you pay me $100, then you will get an A in the class. That's the conditional. So that's my P implies Q. Pay me $100 is P. Getting A in the class is Q. So for that not to be true, what would have to happen? For my promise to be false, what would have to happen is you would have to pay me $100 and I would not give you an A. that is for how that thing fails. So it makes a whole lot of sense logically, which is actually where we're at, this logic stuff. But we could also prove it through through truth tables as well. But yeah, but you can see that in order for, if I'm gonna fail at my promise, then what has to happen is you gave me the $100 and I did not give you an A. I'm gonna erase this so I can stay close to these De Morgan's definitions. As you go through the homework in this section, you're going to be asked to apply De Morgan's laws. And so we'll look at that for a minute. I'm going to just take a peek at the homework. Your homework starts out with 1 through 13. Okay, I apologize, I had lost it for some reason, it went away. 1 through 13 and then jumps. So I think in that 1 through 13, let me just go down and double check. I want to stay close to your homework. Yeah, they're asking you to rewrite things using De Morgan's laws. So I want you to look at something like number 4. So what they won't have is just you rewriting the same thing. In number 4, they have the negation of P or the negation of Q. If we're going to apply De Morgan's law, so what's in black is what's given. Actually, let me do a couple of things. What's in black is what's given, and they would like you to write an equivalent statement using De Morgan's laws. Well, De Morgan's law, which one applies? It is the top one for us that applies. And what happens is we negate the first thing. Negating the negation of P, right? If you negate the negation of P, you just get P. If you negate the negation of Q, you just get Q. So those are those guys flipped. And remember, we always turn around the thing in the middle. So we are applying this very first one right up top here. And we get P and Q coming out of that. So pretty awesome there. That's number 4. If we go into the next group, it says, the directions for the next group says, for the following exercises, using De Morgan's laws to write the negation of each statement in words without using the phrase. It is not the case that. So if I go in here and say number 8. Number 8 says this: Ralph Macchio was the original Karate Kid. And karate is for defense only. So they'll just put 2 statements in there, and what they're asking you to do is use De Morgan's laws to write the negation. Okay, so what do we have here? We have Ralph Macchio was the original Karate Kid, and, right, the Karate Kid is for defense only. And what is, they're asking us to negate that, and we know from De Morgan's laws that that's equivalent to the negation of P, the negation of Q, but with an or in between, right? It's the one right at the top of the screen. So I'm just rewriting De Morgan's law, but now I got to put this piece in words. So the negation of P, Ralph Macchio is or was not the original Karate Kid, or the Karate Kid, or karate is not for defense only. Done. Now that makes sense. If we're gonna say that Ralph Macchio is the original Karate Kid and the Karate Kid is for defense only is not true, right? If we're gonna take the negation of it, then either the first thing is false or the second thing is false. They could both be false, but either one or the other is false. Okay, but even if it doesn't make sense to you, I think it should from a logic point of view. You're just applying De Morgan's law. So you're back to section 2.1 really, just writing the negation of statements. You're following the path that's led here by the second one that we listed up top here, right? You're following this path and you're just rewriting. So it's a combination of 2.1 and 2.2. Well, that happens in 5 through 10, right? You're doing those types of things. Then you get to 11, 12, and 13. Let's look at number 12. They want us to use De Morgan's laws to take the negation of P heading to the negation of Q. Well, what would we use? We're going to use this number 3 right up top. In fact, let me do something that I think will be helpful. I'm going to just move this closer to where we made those original statements. So just come in here and erase a little bit. In fact, let me switch to the type of eraser so it goes a little bit quicker. And I'll move this number 12 up. Okay. So why do I want to be doing all of this? Just so you can see the original De Morgan's laws, right? So here I am, more than halfway through the homework, and I got this number 13 in here, which is saying, hey, use De Morgan's laws to take, oh, let me do number 12, to take the negation of P heading to the negation of Q. Well, we know according to De Morgan's laws, let's be really careful here. According to De Morgan's laws, this is equivalent to, and it's the one right above it, the first thing, P, an and sign always, and the negation of the second thing. So in this case, I'm going to take the negation of Q, and that's going to be Q. So P and Q is equivalent to P going to the negation of Q by De Morgan's laws. And so that's what's happening in those. As we move forward from there, we stay true to the homework, we get into some wording. I stop at 13 because they start putting in a third variable there, which I don't think we need to deal with. For the following exercises, write the negation of each conditional in words. So essentially, the next group of problems is having us look at a conditional statement and write the negation in words. So if we look at 20 as an example, if a person does not pass their road test, and then they will not receive their driver's license. And you could go and somebody could tell you, hey, that was false. You know, that didn't happen in my case. Well, they're just asking us to use De Morgan's law. So remember, P is somebody not passing their road test. Q is not receiving their driver's license. So the negation of that P implies Q would be, well, we know it's P happening and then Q not happening. So what would the negation be? It would be a person. For that not to be true, what would have to happen is a person does not pass their road test and they received their driver's license, right? That's the opposite of Q. So you can see that it's a combination of 2.1 and 2.2, taking negation of statements, putting the word and in there. And that's what takes place as we go through the remainder of the homework, is just that type of work. There is an exception. At the very end, you have 33 and 34. And what the 33 and 30, well, you'll have 33 and 35. I'll look at 34. It's going back to the last section. They want you to show that two statements are equivalent. So they want you to show that P implies not Q is equivalent to not P or not Q? Well, you're not thinking much about that. They could have easily put this in the last section. So what do? Well, you know what to do because you did the last section's worth of homework. You just established truth tables for each. And let me be careful here. I made a small error. I need to establish the not Q column, and then we'll look at P implies not Q. Well, let's do it. True, true, false, false. True, false, true, false. Not Q would be false, true, false, true. And then we have P implies not Q. So because I can, I'm going to come in here and erase this Q column because I don't really need it anymore. I'm going to come back here and go to red just to make sure we're going in the right direction. Our arrows are going this way. And so what do we have? We have true implies false, so that's false. True implies true is true. False implies anything is true, right? Because we know that conditional. And so in this truth table, we have a false followed by 3 truths. Well, that's what we need to happen over here as well. So over here, we need P, Q. We need not P, not Q. Oops, I made that really long. Let's see, not Q. And then not P or not Q. And now we have true, true, false, false, true, false, true, false. Not P would be false, false, true, true. Not Q, opposite of true is false, opposite of false is true. But we're really good at this by this point. And then we have our OR. Well, remember with OR, and again, let me just remind you, we're looking at 2 very specific columns here. We're looking at these truth values. The other ones were just there to help us build up. So I'm erasing those in the video because I can, so that you know where to focus on. Remember that an OR is true almost always. The only time it's false is if they're both false, which is that top one. But as long as somebody's true, the whole thing's true. And that's the result of that truth table. Well, take a look. We're 100% equivalent because we have a false followed by 3 truths in each case. Done, right? That's what you would do to show and ultimately write, yes, they are equivalent. And so that's happening at the very end. Why talk about equivalent statements here? Because that's exactly how these De Morgan laws were originally found, right? It's just by looking at equivalent statements. It's very logical though, right? If we look at this conditional again, if a person does not pass their road test, then they will not receive their driver's license to be false. If somebody said, that's not my experience, then what happened? They didn't pass their road test and they still received their driver's license. That's what we're saying here, right? That's what De Morgan's law is saying. Right? They didn't pass their road test and they received their driver's license. So think about it, try these problems. I think you'll find that they're very straightforward and nice, but if that's it, I think that's the case. If it's for some reason that's not happening for you, no problem. Just